We're going to go ahead and look at applied problems today. Basically, we're going to be looking at right triangles, and if you're asked to solve a problem or solve a triangle, that means you're going to be wanting to find all the missing sides and all the missing angles. Now, today we're limiting ourselves to just looking at right triangle stuff. There is also a lot of application that can be done with non-right triangle stuff, but that's what we'll be considering in Chapter 8. Now, for what we're going to be dealing with, angles are always capital letters. Lowercase letters are the sides opposite those angles. And for what we're dealing with, C is going to be your right angle. So that means angle A and B are going to be your acute angles. By the way, if a problem throws Greek letters at you, angle A corresponds to alpha. Angle B corresponds to beta, and then angle C corresponds to this funny looking Y. So if you happen to see these Greek letters, just know it's referring to A, B, and C. So here you're given a side and you're given another side. So what I would do is, first of all, draw myself a right triangle. I know that angle C is my right angle, so side C is my hypotenuse, which is 8, and then A's got to be one of my legs. So I'd have a triangle that looks very similar to this. So we need to go ahead and solve this triangle. So that means we got to find all of our missing sides and angles. So we could go ahead and find, we know angle C is our right angle. We could go ahead and find B. If this is B, this is our adjacent, this is our hypotenuse, so that means we'd be dealing with cosine. And the cosine of our angle B is equal to our adjacent over our hypotenuse, which it simplifies down to root 3 over 2. Now, when is cosine equal to root 3 over 2? That's one you're supposed to have memorized. So that's 30 degrees. By the way, if angle B is 30 degrees, and you know that that's right angle, you know angle A is 60 degrees. So then you can go ahead and find your missing side. You could use what we just figured out here, and so we could go sine of our angle 30 would be equal to our opposite of B over our hypotenuse. And you know the sine of 30 is 1/2. You'd have 1/2 equal to this, and we get B to be 4. You could have also have used the Pythagorean Theorem. Could have went to your A squared plus B squared equals C squared. But I like that approach because then you're not relying on what you found out to be this. Because if you would have made a mistake in finding angle B and then used that answer to find out side B, well, then that would automatically throw that one off. But if you made a mistake in finding angle B and then use what you were given, meaning the Pythagorean theorem here, to find angle or side B, then you could still get that right even if you got your initial angle wrong. So here you're given alpha, which remember is angle A, and you're given the side of A. So first of all, draw yourself a right triangle. So with our triangle drawn, we would have something similar to this. Now remember, this is degrees, minutes, seconds. Our side opposite. Now we know C over here is 90 degrees, and we know all the angles in a triangle add up to 180. So to find angle B, we should be able to go 180 minus the other two angles, or because A and B, alpha and beta, have to add up to 90, you could just go 90 minus this and type it into your calculator. Remember, you can type in degrees, minutes, seconds, and then to get this back out, you'd have to DMS it, and that's using second apps, which is your angle menu. So if we want to go ahead and find C first, we would have our angle, we'd have opposite, we'd be looking at hypotenuse. We know that that's this. So we go sine of our angle is equal to our opposite over our hypotenuse. Then we'd have to go ahead and multiply both sides by C to get C out of the bottom. And then we could finish getting C solved, and we get our calculator ready form. We type that in and we get this. We're not concerned about exact answers here because in the last problem we were dealing with angles that we were supposed to have memorized. Here, 31 degrees, 10 minutes is not one you're supposed to have memorized, so decimal approximations are perfectly fine. So now, if we go back to what we're given, we were given our angle and our opposite, and if we were looking for this, which is adjacent, then that would be tangent. So we go tangent of our angle equals our opposite over our adjacent. Once again, we got to get our variable out of the bottom, multiply both sides by b, and then you can finish getting b by itself. We get our calculator ready form, and then you type it into your calculator to get your approximation. So here I'd first of all draw myself a triangle. Remember, this is like angle A, that's side opposite of A, that's your angle, or side B, opposite angle B, and C, remember, is your right angle. So here's your angle, here's your opposite side of A, side B would be adjacent. So you got to think, okay, here's my angle, I'm dealing with opposite and adjacent, that's tangent. So I could go tangent of alpha equals my opposite over my adjacent. Now, they want you to find A. So in other words, they want A on one side by itself. Well, to finish getting A by itself, you'd have to get rid of dividing by B. So you get tangent of alpha multiplied by B is what A is. So take a moment to read through this. Then draw yourself a picture. So you have your clouds, you have your spotlight, you know you're going straight up, it says, and you have a point P that is d meters away from the spotlight, and you're on the ground. So here's point P, you're d meters over. So our angle going up to the clouds is alpha, it says. Our angle of elevation, that's going from the horizontal up. So we're dealing with our angle, we're dealing with opposite, we're dealing with adjacent, so that means we're dealing with tangent. We could go tangent of our angle equals our opposite of h over our adjacent of d. It wants h in terms of d and alpha. So that means it wants h by itself. To get rid of dividing by d, you'd multiply both sides by d. So now in the second part, they're telling you what d is. You're telling you what your alpha is. So you could take 1000, put it in for d, alpha, plug it in 59. That's our calculator ready form, and we type it in. So here we have a water slide. Our water slide goes down here, levels out a little bit, and then finishes up. That's your water slide. So for this problem, we need to figure out the length of that highlighted part that I just drew in. I'm going to get rid of that so we can work this out. But first of all, you'd have to figure out, well, what's the length of the purple? Well, when you look at your right triangles here, you have your angle, you have your opposite, and then you'd have your hypotenuse. You know that you're going to be dealing with sine. Sine of your angle equals your opposite over your hypotenuse. And I'm calling my hypotenuse y in this case. Notice y is in the bottom, so I'd have to multiply both sides by y, so I get y sine 35 is equal to 15. Finish getting your calculator ready form and type it in. So that's the purple. Also, I'd need to know the red. Well, once again, I have my angle, I have my opposite, I'd be dealing with my hypotenuse, so that's sine, so it'd be sine of my angle equals my opposite over my hypotenuse, and I'm calling my hypotenuse x. X is in the bottom, so I'd multiply everything by x to get it out of the bottom, and then divide to get my calculator ready form. Now, I know the whole distance horizontally left to right is 1000, but I don't know this color right here, the horizontal in the middle. Did I say 1,000? That's 100. Sorry. But if I got rid of this green here and got rid of this green here from my 100, that would tell me what I'd have left over here. So to figure out this green here, that's adjacent to my angle, and I have my opposite. So I know I'm going to go tangent of my angle equals my adjacent over my, or opposite over adjacent. Get z out of the bottom by multiplying by z, and then get rid of the tangent by dividing. I get my calculator ready form, and I type it in. Over here, I have my opposite, and I'm dealing with my adjacent. Once again, that would be tangent is equal to opposite over adjacent. Multiply everything by a, and then I'd have to divide by tangent 25 to get my calculator ready form. So from here all the way to here is 100. But this part is 100 minus this green one minus this green one. So that's what I'm going to do. Take the whole horizontal distance minus my two green ones, and that's going to tell me what I have here in the center. So now I should be able to go ahead and find the length of my slide. I'd have the purple plus the horizontal plus the red. So the horizontal plus the purple plus the red, add them together, and I get this. And so I'd say it's about 108 feet. Also, just to help you understand what angle of elevation and angle of depression is, it's always your angle from the horizontal. So if you're up here at Split Rock Lighthouse looking down at Lake Superior at a kayaker, if you go straight out and then rotate your eyes down, your angle of depression would be how many degrees you're down from the horizontal. Depression means you're going down. Angle of elevation is really still going from the horizontal and looking up. So if you were the kayaker down here on Lake Superior looking up at the lighthouse, your angle of elevation would be here, where you start at the horizontal of the lake surface, and how many degrees up you have to tilt your head to be able to see the lighthouse is your angle of elevation.